Hi, in this video we're going to work on multiplying fractions and mixed numbers. The idea here is to show how to model it so we really understand what we're looking at, more than just how to do something. So what we're going to notice here is we have a rectangle, and that rectangle is a poster. The poster is supposed to be 1 1/4 yards wide and 3/4 long. They want to know what the area is. Now we should remember that the area of a rectangle is always the length times the width. All right? Knowing that, I know that I will be multiplying a fraction by a fraction. That was supposed to change color. So, when I'm multiplying any two fractions, I know that I'm actually decreasing my value because I'm taking a part of something. All right, that's the key word for multiplication, of. I will be taking a quarter of 3/4. I'm not even starting with a whole. I'm already starting with part of something that's not filled, because that would be 4/4. So, if I'm looking at that, I'm saying I have 3/4. The first thing I'm going to do is I'm going to separate my poster into fourths. As you can see, I have 1, 2, 3, 4 parts, because that's a whole poster. So I need all 4 parts, and I'm only going to use 3. The next thing I need to do is I need to separate my width into fourths as well, because that's what my denominator is telling me. And if I really pay attention, I should have 16 boxes over here when I'm finished, because 4 times 4 is 16. So I'm going to go ahead and separate this into quarters. I like to do half and then 2 more halves, just like that. And as you notice, if you were to count, which I'll do for you anyway, because why not? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 16 pieces in my whole, and that makes sense because the denominator will always tell you how many are in one, whereas your numerator will tell you how many you have. So, if I were to do the algorithm, right, I'm pretty sure we can all multiply straight across, and we know that my answer should be 3/16. But what does 3/16 mean? Unless we show what it means. So what I'm going to do first is I'm going to go over here, and I'm going to work on my 1/4. I'm going to show you what a quarter is. A quarter, we said, we drew our lines first of all vertically, is let's get rid of a quarter. There, I just filled 1/4. I still have 2, 3, 4 quarters left. I did not use those. Now, a completely different piece in an opposite direction, I need to do 3/4 as long. So what I'm going to do is I'm going to start, and I'm going to do 3/4. 1, 2, 3. And I leave the one on the bottom over here blank, because I don't want to touch this. This is not used. And then what I'm going to see is these are areas that I covered, all right? I have 3/4 of a poster. This is 3/4. And what I wanted to know is, of this area, just this area, we don't care about down here, just about up here, I want to know what 1/4, 1, 2, 3, 4, of this area is the value. And it turns out that it's 1, 2, 3, whoa, out of the 16 that the entire poster represents. All right? What I want to do here is I want to take a look at what happens when, we have an improper fraction, meaning a value greater than 1. All right? Here we're saying that in a whole, there are 4 sections. I have an extra section. I just have to remember that when I do my problem, because when I set it up, I need to make sure I have more than one whole. So I have 5/4 times 2/3, because again, we want the area, and area is length times width in a rectangle. So what do I have? Well, here I have 5/4. The first thing I'm going to do is I'm going to draw a garden. Boom, there's a garden. I realize that in one whole, I'll have 4 pieces. Problem is I have 5, so I'm going to spill over. So why not, at first, just there, make 2 holes. Now I have 2 holes. You know how I know I have 2 holes? Because there's 2 pieces there and nothing subdivided, right? Right. So my goal here now is to break it up. I have to break this up into quarters. So each one is going to be broken into quarters. Half and half again, and again. And then on my second one, I'm going to do the same. And as you notice, I'm going to have 1, 2, 3, 4, there's 1 hole, 5, 6, 7, 8 pieces. Now, that's going to make sense because, just make that so you can still see that I have 2 separate boxes. If I were to have, if I were to have 4 in 1 hole, it would make sense then that if I had 4 in 1 hole and I had 2 holes, I should have 8 pieces, which I do. Now my job is to fill 5 of them, but not yet. The other thing I need to do is I need to subdivide 2/3, because I want to know what 2/3 of the 5/4 is going to be. So here, I'm going to separate in the opposite direction. I'm sorry about the angled lines. I'm doing this on an iPad. Into 2/3. Well, actually 3/3. We have 1, 2, 3/3. All right, but I only care about 2 of them. So I'm going to see what 5/4 and 2/3 is going to equal. So what I'm going to do is I'm going to take my 5/4 and I'm going to fill them in. Remember, those were the vertical lines, so I'm going to go down them vertically. There's 4/4, which is 1 hole. Here's 5/4, all right? And we should know that if I were to take a hole out, which is 4/4, I'd have 1 hole and 1 left out of 4, which I do. I have 4 holes right here, well, 4/4, which is a hole, and 1/4 left. Now I need to take 2/3 of that 1/4. So in the opposite direction, let's take 2/3. And there we go. I have 1, 2 out of 3. Now my answer is going to lie wherever my cross sections are. Right there. All right? And what we're going to do is we're just going to count them. We have, let's get a little dot over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 as a value. But what is it 10 out of? Well, we got to remember, we're not doing 10 out of 2 holes. It's always out of 1 hole, okay? So when I really look back, I should be looking at, oh, wrong button again. I'll get used to this. 4 times 3, which will give me the value in 1 hole, which is 12. And you can see that here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 pieces to 1 hole. So when I look at what 2/3 of 5/4 are, remember, I'm only taking every 2 out of 3 out of 5 out of 4. And that's a lot of ofs. We're going to end up with 10/12 because 5/4 ends here. And if I'm counting every 2 out of 3, I'm thinking 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. All right? I hope this helped. And I should be back with another one that explains even more of if you end up with an improper fraction as a final answer.